All right, Algebra 1ers, here we go. Day number 2 of multiplying monomials with coefficients. Now, this is going to be the newest part that we're going to see today, and it's really not a very difficult concept to deal with. Let's just kind of do a little quick review that when we end up multiplying two expressions that have an exponent on them, and we use multiplication between the two, we end up adding the exponents upstairs. So it's an addition between the two exponents when you do a product concept. So this would be like x to the 5th power. Now what we're going to add today is that, yeah, you've been able to add these two values together relatively easy to get the full entire exponent. But what if we actually put a number right out here in the front of these two values, and we ended up saying, well, what are we supposed to do with the coefficients on the front end of this? Now, the answer to that is that they work out pretty straightforward, and here we'll go and explain. So when we start to multiply things like this m to the 6th and this m to the 2nd power, we would definitely say, since it's multiplication between the two, we would add the exponents together and get a 8 that would be in the upstairs part of this. Now, the question we want to ask is, what are we going to do with these numbers that are in the actual front of this? Well, they are just like any other multiplication concept. We will straight up multiply these two numbers times each other. So we'll just get a number like 32 m to the 8th power. Okay, and that's the only thing that's really going to take place in all these coefficient ones. So there's a number in the front, fronts times fronts, and then you're going to do your exponential variables and add them together. So ultimately, it's just going to be the very first thing we're going to fall out on here is we're going to multiply the fronts times each other. Now, if you have to write them next to each other, that's probably not a bad idea. So like 2/3 times 3/4, and then I would get something like x to the 9th power. Now you can see that those coefficients should work with each other, and even in this fractional sense, you can see some cross-canceling that would really be super helpful in helping us get down to a reduced answer. So the 3's canceled, made 1's, the 2 and the 4 made a 1 and a 2, and if I multiply top times top and bottom times bottom, I'm basically dealing with 1/2 x to the 9th power. And that would be your final answer on that. Now, don't be surprised. Sometimes they might write these answers where like the x to the 9th power could be written as an upstairs component. X to the 9th divided by 2 is equivalent to this. It's exactly the same thing. I actually prefer to put the coefficient in the front. It makes more sense because you're like, oh, I see it out there in the front, and you can do it, okay? Now, same kind of idea, number 3. Put the coefficients next to each other as a multiplication, and then make sure that you remember that you're supposed to add the upstairs components. And I'm going to even write this one out as 1/3 plus 5/3 as the power, so you can really see what's going on there. I multiply coefficients, and I add exponents. So -8 m, and if I add 1/3 and 5/3, I would end up with 6/3. And always take a look at things that you can possibly reduce. This would be -8 m to the 6/3 is really just the number 2. And this would be the absolute reduced monomial answer that you would get out of the end of this, all right? Now, there are a couple of them that I'm going to see down here below that I want you to all try on your own. Now, I know they're labeled A, B, and C, and I'm going to take a couple of seconds of blank space, pause this, pause the video, try it on your own, these 3, and then I will show you the solutions. And poof, there's the answers that you should have got in that A, B, and C section on your notes. Taking a look here, I did 3 times 2. That was the 3 times 2. I don't make that look like a multiplication. Is 6, and then I added the exponents for 6y to the 5th. This one, -3 times 7 is -21. Keep note that if you don't have an exponent, those are 1's that are sitting on those. So those two added together, a to the 2nd power. And then down here on the end, 6 and 1, it's in the front on this guy. So 6 times 1 and p to the 5th power. So hopefully you got all of those correct. Now, let's take a look down here below and some other questions that you might run into, and making sure that you get the right components that are on there. Now, if you see negatives that are on the fronts of these, you can better yet think of those as being negative ones that are sitting on there. So if you can't see the coefficient because it's just a negative, you can basically see it like that there is a negative 1 on each one of those. And coefficients multiply coefficients like we've been doing in the past. So a negative 1 times a negative 1 would be a total of 1. That takes care of those. The a to the third doesn't really multiply anything, so it's still just going to stay a to the third. And this b to the first power is going to multiply this b to the first power, and we'll end up with b to the second power. So you're looking at each one of the individual multiplications and writing them all out, okay? Now, number 5. Now, number 5, I would be very cautious about. This is an easy one to make a mistake on because it specifically revolves around this guy right here. When we're thinking about this power again, if there is no parentheses around this concept, then this power is really only applying to the 2. So a better way to really write this question would be that it's really a negative 1 times 2 to the second power times 2 to the 6th power. And that negative 1 that's sitting out there in the front is a coefficient concept, and these bases now match each other like they should. And if those bases do match, I can add the exponent that's going on in there. So it'd be a negative 1 times 2 to the 8th power. Now, 2 to the 8th power can get kind of a little bit cumbersome. I'm going to remind ourselves that if you have a calculator that has a power key on it, this could be really super helpful. So 2 raised to the 8th power is going to be the number 256. But then ultimately that number 256 is going to be multiplied by negative 1, and you're going to get a negative 256. And that would be your final answer here, negative 256. And if you ever have ones that are just numbers, your best answer is to evaluate it all the way down, okay, so that it's completed. Now, again, you might have coefficients on several monomials as you go down. Here's a negative 4 right here. There's a 1 on this one and a 3 on that one. So if you want to write them all out times each other, that's a good idea. So you have all the coefficients together, and then you can start to see which ones of the powers would add together. That would be a j to the second plus a j to the first would be j to the third, and a k to the third, because there's nothing else there. And ultimately, these all multiplied by each other would be negative 12. So negative 12, j to the third, k to the third, and you'd have your completed monomial. So it's just about being cautious as you go down the line of what you're dealing with. Now, no coefficients out here on the fronts of these. Bases match. 8 to the 9th power. Holy moly, that should be a big number, and it needs to be evaluated. Let's see what good old calculator says about that. And whoa, that's a big guy. 314,217, 134,217, and then there's more. Sorry, it made it go away. 728. Ugh, wow. We've got 134,217,728. Evaluate those. And the only reason I can put those together, remember, is because the bases match each other. It's easy to note that they match each other with letters, but you have to match them with numbers to be able to put them together that way. Now, letter E. Let's see what this guy's got. Coefficient in the front is a negative 2. Coefficient in the front is a negative 1. So I really got a negative 2 times a negative 1. C to the third power, D, because there's no other letters that would add together in that particular regard. So basically 2 C to the third D is what you're going to get as your monomial. Pretty simple stuff. All right, letter F. I see all these coefficients that are in the front. Let's get those all multiplied by each other first. Negative 2, negative 1, and negative 5. And then let's see what the A's, B's, and C's do. We've got an A to the first there, and an A to the first there, so that must be A to the second. And if you have to cross them out as you do them, that makes sense. Okay? A B to the first and a B to the third, that would be B to the fourth. Okay? And the negative we took care of with the coefficient, and then a C down here on the end. Now, put your coefficients together. A negative times a negative times a negative would be a negative, and I think that's going to be negative 10, a to the second, b to the fourth, c. You guys have got this. It's really not tough stuff. You just got to be methodical and make sure that you write them out. Now, if they write them out in function notation, don't be scared about that. They're just asking you to take the two ideas and multiply them is really what they're trying to do. So if you have to, write them next to each other so that you can see what's going on. Negative 3x to the third times negative x to the second power. And again, your coefficients multiply first. So that's your negative 3 times your negative 1. And then you add your exponents on the other, so x to the fifth, or 3x to the fifth power is what you should get in the end. Okay? Try letter G on your own. See whether or not you can pull that one off. I'll pause for a few minutes and you can see if you can get it right. All right, check that letter G answer out. Ooh, my favorite letter, letter G. And see if you got that answer correct. Again, the two coefficients times each other right there in the front. Added the exponents because that's a multiplication. We should add exponents, so negative 12x to the 10th. All right, guys, you're going to be this is going to be an easy assignment. You're going to blast through it, practice it so that you are very proficient at it, and because ultimately later on these kind of skills really become very important when it comes to exponentials. Good luck. You guys are going to do great.